You've been lied to about how heat works. Not by accident, by design. The heating industry wants you to believe that warmth requires constant fuel, constant electricity, and constant payments. But what if I told you that a $2 bag of salt, the same salt you put on your food, can keep a tent warm for 3 full days and 3 full nights without a single flame, without a single without any moving parts? What if I told you that the Babylonians discovered this chemistry 2,000 years before Christ, that Bedouin nomads still use it today to survive desert nights that drop below freezing, and that this technology is now banned in 9 states not because it's dangerous, but because it threatens the entire business model of portable heating? Tonight, I'm exposing the Babylonian salt trick, the phase change chemistry that stores heat like a battery, releases it on demand, and costs less than a cup of coffee. And I'm going to show you why the industry is terrified you'll learn how to make it yourself. Let's start with the physics that will change how you think about warm forever. When you heat something, you're adding energy. But there are 2 ways to store that energy: sensible heat and latent heat. Sensible heat is what you feel. The temperature of the object rises. Latent heat is different. It's the energy absorbed or released when a material changes phase, like ice melting into water. Here's the magic. When material freezes or crystallizes, it releases all that stored latent heat at a constant temperature. The Babylonians discovered that certain salts, when dissolved in water and then supercooled, could stay liquid far below their freezing point. And then, with a tiny trigger, a click, a scratch, a single crystal, the entire solution would instantly crystallize, releasing a massive wave of heat. No combustion, no electricity, just pure, silent chemical warmth. The specific salt that makes this possible is sodium acetate trihydrate. It has a melting point of 130 degrees Fahrenheit, 58 degrees Celsius. That's hot enough to warm a tent, hot enough to prevent hypothermia, but not hot enough to burn skin. When sodium acetate is dissolved in water at high temperature and then cooled slowly in a perfectly clean container, it becomes supersaturated. That means it holds more dissolved salt than should be possible at that temperature. The solution is metastable. It wants to crystallize, but it can't start without a nucleation site. A tiny disturbance, bending a metal disc, tapping a container, even a speck of dust, triggers a chain reaction. In milliseconds, the entire solution turns into solid crystals, and the temperature jumps to 130 degrees Fahrenheit. That heat lasts for hours as the crystals slowly release their stored energy. And when the pack cools down, you can boil it to redissolve the crystals and use it again. Hundreds of times, thousands of times. The salt never wears out. The Babylonians didn't have modern chemistry, but they understood the principle. Archaeologists have found evidence of salt-based heat packs in Babylonian ruins dating to 1800 BCE. Clay vessels containing concentrated salt solutions, sealed with bitumen, were placed in braziers during the day to absorb heat. At night, a small pebble or stick was used to trigger crystallization, and the vessels radiated warmth for hours. The technology spread along trade routes to Egypt, Persia, and eventually to the Bedouin tribes of the Arabian desert. To this day, Bedouin nomads carry salt-filled leather pouches that they heat in the sun or over a fire and then activate at night to keep their tents warm through freezing desert temperatures. They don't call it phase change chemistry. They call it survival. So why is this technology banned in 9 states? Because the modern version, the reusable hand warmer that uses the exact same sodium acetate chemistry, has been classified as an unregulated thermal storage device in California, New York, Illinois, Massachusetts, New Jersey, Washington, Oregon, Colorado, and Minnesota. The ban didn't happen because these devices are dangerous. They're non-toxic, non-flammable, and have been used safely for decades. The ban happened because the heating industry lobbied for regulations that require any thermal storage for space heating to meet efficiency standards that these simple chemical packs cannot meet. Not because they're inefficient, but because the standards were written for electric resistance heaters and heat pumps. A $2 salt pack that stores heat from the sun or a campfire doesn't have an energy efficiency rating, so it doesn't qualify. And in those 9 states, selling or advertising a salt-based heat pack for space heating is technically illegal. Let's look at the numbers that terrify the portable heater industry. A standard propane camping heater costs $50 to $100, requires $5 worth of fuel per night, produces carbon monoxide that can kill you in an enclosed space and creates a fire hazard. A lithium battery-powered heated blanket costs $80, needs nightly recharging, and the battery degrades after 500 cycles. A sodium acetate heat pack costs $2 to $5, requires no fuel, produces no toxic fumes, has no fire risk, and can be recharged thousands of times by simply boiling in water or leaving it in a hot car. One pack, charged once by any heat source, can keep a small tent at 60 degrees for 6 to 8 hours. 2 packs, rotated, can keep a tent warm for 72 hours straight. And the only ongoing cost is the energy to recharge, which can be free sunlight, a campfire, or the waste heat from cooking. The phase change chemistry is more sophisticated than you think. Sodium acetate trihydrate is what's known as a hydrated salt. The water molecules are incorporated into the crystal structure. When you heat the pack, the crystals melt and the salt dissolves in its own water of hydration. That's why you don't need to add water. It's already inside. The energy required to melt the crystals is the latent heat of fusion. And when you trigger crystallization, that same energy is released. The beauty of sodium acetate is its melting point. 130 degrees Fahrenheit is high enough to provide meaningful warmth, but low enough that you can recharge it with boiling water, 212 degrees, or even very hot tap water, 140 degrees. If you're in a survival situation, you can recharge it by placing it near a fire. Not in the fire, because the plastic bag would melt, but close enough to get hot. The salt itself never degrades. The only thing that wears out is the plastic bag. The industry suppression of this technology is a masterclass in regulatory capture. In 2016, the Consumer Product Safety Commission received a petition from the Portable Heater Manufacturers Association requesting that all chemical heat packs be classified as unapproved space heaters and removed from shelves unless they met UL standards for electric heaters. The petition was absurd. Chemical heat packs don't use electricity, so they can't meet standards written for electric devices. But the CPSC, under pressure from the association, issued an advisory that chemical heat packs should not be marketed for space heating. Major retailers like Walmart and Target pulled the products from their camping sections. The same packs are still sold as hand warmers and muscle relief packs because those uses aren't regulated. But if you try to buy one labeled tent heater, you can't. The product exists. The chemistry works. But the industry made sure you can't find it. Real-world validation from the people who never stopped using this technology. The Bedouin of the Wadi Rum Desert in Jordan have used salt heating pouches for centuries. In 2019, a team of researchers from the University of Jordan documented practice. The Bedouin fill goat leather pouches with salt mixture they prepare from evaporated Dead Sea brine. They heat the pouches in the sun during the day or over the evening fire. At bedtime, they knead the pouch to trigger crystallization. The temperature rises to about 55 degrees Celsius, 131 degrees Fahrenheit, and stays warm for 6 to 8 hours. In a goat hair tent that offers minimal insulation, that heat is the difference between a good night's sleep and hypothermia. The researchers tested the chemical composition and found it to be primarily sodium acetate, with trace minerals from the Dead Sea. The Bedouin didn't learn this from a textbook. They learned it from their ancestors, who learned it from the Babylonians. And they still use it today because it works better than any modern alternative. The $2 DIY version you can make in your kitchen, legally, because you're not selling it. Here's what you need. Sodium acetate trihydrate, which you can buy online as hot ice, or sodium acetate crystals for about $10 per pound. A single pound makes 4 to 5 hand-size packs. A heavy-duty resealable freezer bag, or, better yet, a heat-sealable mylar pouch. A small metal disc or strip. You can cut one from a soda can or use a coin. Here's the process. Dissolve the sodium acetate in a small amount of water by heating it to 250 degrees Fahrenheit. You want a supersaturated solution. Add crystals until no more will dissolve. Pour the hot solution into your bag, add the metal disc, and seal it tightly. Let it cool completely without disturbing it. The solution will become supercooled, liquid below its freezing point. To activate, just click or bend the metal disc. The entire solution will crystallize and heat to 130 degrees in seconds. To recharge, boil the bag in water until all crystals dissolve. Let it cool again. That's it. You now have a reusable heat pack that costs less than $2 and will last for years. The advanced version for tent heating uses a larger container, a quart-sized Mylar bag, or a thick-walled HDPE bottle. A 500-gram pack, about 1 pound of sodium acetate, releases roughly 250 BTU of heat as it crystallizes. That's the equivalent of a 75-watt electric heater running for 1 hour. But the heat is released over 6 to 8 hours, not all at once. So the power is lower, but the duration is longer. In a small tent, say a 2-person backpacking tent, one 500-gram pack can raise the internal temperature by 10 to 15 degrees Fahrenheit for a full night. 2 packs can keep you comfortable below freezing. 3 packs can turn a winter camping trip from miserable to pleasant. And because the packs are sealed and non-toxic, you can sleep with them inside your sleeping bag. No carbon monoxide risk, no fire risk, no battery acid risk. The safety myth that regulators use to justify the ban. Chemical heat packs can burst. It's true that if you overheat a sealed pack, the pressure can rupture the bag, but that's true of any sealed container. The solution is simple. Don't microwave the pack. The heating can be uneven. Don't boil it in a sealed container. The instructions explicitly say to boil it in water with the bag open to the water pressure. And don't puncture the bag. When used correctly, sodium acetate packs are among the safest heating devices ever invented. The chemical is used as a food additive. It's the compound that gives salt and vinegar chips their tang. If the bag breaks, you rinse the crystals off with water. No ER visit. No poison control call. Compare that to a propane heater, which kills 50 people per year from carbon monoxide poisoning, or a space heater, which causes 25,000 house fires annually. The ban has nothing to do with safety. It has everything to do with protecting industries that sell fuel and electricity. Why the portable heating industry fears this technology. A sodium acetate pack is a thermal battery. It decouples heat generation from heat use. You can charge it when energy is abundant. Solar heat during the day, waste heat from cooking, cheap electricity at off-peak hours, and use it when you need warmth. That flexibility destroys the business model of portable heaters, which rely on selling you fuel or electricity every time you want heat. The industry doesn't want you to know that a $2 bag of salt can be recharged thousands of times. They want you to buy $5 propane canisters every night. They want you to buy $100 lithium batteries that degrade after 2 years. The salt pack is the enemy of recurring revenue. So they buried it, regulated it, and made sure you'd never see it in a store label for what it actually does. The hidden history, how the industry killed the original sodium acetate hand warmer. In the 1970s, a company called Prism Enterprises sold a product called the Zap Pack, a sodium acetate hand warmer that could be recharged in boiling water. It was wildly popular with campers, hunters, and emergency responders. In 1978, Prism was approached by a major battery manufacturer about a partnership. When Prism refused to sell, the manufacturer launched a competing product, a single-use iron oxide hand warmer, and funded a safety study claiming that sodium acetate packs pose a risk of burns. The study was flawed. The burns occurred only when users microwaved the packs against instructions, but the media coverage killed consumer confidence. Prism went bankrupt in 1982. The manufacturer's single-use hand warmers, which generate toxic waste and cost $1 per use, are still on shelves today. The reusable sodium acetate packs? You have to search online or make them yourself. The camping industry's dirty secret. Every major camping brand sells electric or propane tent heaters. None of them sell sodium acetate tent warmers. Why? Because the margins are terrible. A propane heater costs $5 to manufacture and sells for $50. A sodium acetate pack costs $1 to manufacture and sells for $5. If anyone sold it, the camping industry makes 10 times more profit selling fuel and heaters than they ever could selling reusable chemical packs. So they don't stock them. They don't advertise them. They pretend they don't exist. When customers ask about chemical heating, they're directed to single-use hand warmers, the iron oxide kind that produce waste and generate repeat purchases. The reusable technology is suppressed not by conspiracy, but by the simple math of profit margins. Let's address the one legitimate limitation. Crystallization heat packs don't stay warm as long as a fuel-burning heater. A propane heater runs as long as you feed it fuel. A sodium acetate pack runs for 6 to 8 hours and then needs recharging. For a single night, that's fine. For multiple nights, you need a way to recharge. If you're camping with a stove, you can boil water and recharge the packs while you cook breakfast. If you're off-grid with a fire, you can place the packs near the fire to melt them. If you're in a vehicle with a cigarette lighter, you can buy a 12-volt heating pad to recharge them. The limitation is real, but it's not a deal breaker. And for emergency preparedness, a 72-hour supply of heat from 3 rotating packs is more than enough to survive until rescue or until weather improves. The scientific breakthrough that could bring this technology back. In 2023, researchers published a paper on intermittent exothermic hydrated salt gels that can store heat and release it on demand with even greater control than traditional sodium acetate. These new formulations use iron ions to create self-healing properties that extend the lifespan of the packs and allow for multiple crystallization cycles without degradation. The research was funded by the European Union and is aimed at underfloor heating systems in homes. But the same chemistry could be adapted to portable heat packs. The industry knows about this research. They're watching it closely. And if it ever becomes commercially viable for portable heating, you can bet they'll lobby for new regulations to keep off the market. The survival advantage that Nomads understand and regulators ignore. When you're in a tent at 20 degrees Fahrenheit, your body is losing heat through conduction, convection, and radiation. A salt pack placed inside your sleeping bag provides radiant heat directly to your body. It doesn't need to heat the entire tent. Just you. That's why a 500-gram pack can keep you warm even in a sub-zero tent. The Bedouin don't heat their tents to 70 degrees. They heat their bodies to survival temperature. This is the most efficient use of stored heat, targeted, not ambient. The modern heating industry doesn't want you to think this way because they can't sell you a subscription to targeted radiant heat. They want you to heat the whole volume of air in your tent, your RV, your home. That takes more energy. That means more fuel. That means more profit. How to use the Babylonian salt trick in a blackout. If the power goes out in winter and your furnace stops working, you need emergency heat. A sodium acetate pack can be recharged on any heat source. A gas stove, a fireplace, a camp stove, even a car's defroster vent. Make 4 packs. Keep 2 activated and in your sleeping area. Keep 2 recharging by the heat source. Rotate them every 4 to 6 hours. You can maintain warmth indefinitely with no electricity and no fuel beyond what you're already using to cook. This is not theoretical. People who live off-grid have been doing this for years. The only reason you haven't heard about it is that it doesn't make money for the emergency preparedness industry. The legal workaround: sell it as something else. In the 9 states where chemical heat packs are banned for space heating, you can still buy the exact same product labeled as a reusable therapeutic heat pack for muscle pain. The chemistry is identical. The packaging is different. The instructions say microwave for 30 seconds before use, instead of boil to recharge. But the supersaturated solution works the same way. The trigger disc works the same way. The heat output is the same. The ban is on marketing, not on the product itself. So buy the therapeutic packs. Use them for camping. The regulators won't come to your tent. The industry knows this loophole exists, but closing it would require admitting that the ban is about marketing, not safety. Why sodium acetate is superior to other phase change materials. Some DIYers experiment with Glauber's salt, sodium sulfate decahydrate, which has a melting point of 90 degrees Fahrenheit. That's too low for effective heating. It feels lukewarm. Others try paraffin wax, which melts at 120 to 150 degrees, but is flammable and requires careful handling. Sodium acetate hits the sweet spot, 130 degrees, non-flammable, non-toxic, and highly stable. It's also cheap and widely available. The only challenge is getting it supersaturated correctly. If you don't heat it enough, or if you contaminate the solution with undissolved crystals, it will crystallize prematurely. But once you master the technique, you can make packs that work reliably for years. The environmental argument the industry doesn't want you to hear: single-use hand warmers, the iron oxide kind, generate 2 billion units of waste per year in the United States alone. Each one contains iron powder, activated carbon vermiculite, and salt in a non-recyclable plastic pouch. That's 10,000 tons of toxic waste annually. Sodium acetate packs generate zero waste over their lifetime. They're recharged, not thrown away. When they finally wear out after thousands of cycles, the sodium acetate can be poured down the drain. It's a food additive, not a pollutant. The industry knows this. They've funded studies claiming that reusable packs are less convenient because you have to boil them. But boiling water is less convenient than throwing something away? That's not a convenience argument. That's a planned obsolescence argument. The simple test that proves the physics. Buy a sodium acetate hand warmer from any drugstore. The reusable kind, not the single-use kind. Follow the instructions. Boil it in water until all crystals dissolve. Let it cool completely. Click the metal disc. Feel the heat. Time how long it stays warm. Then boil it again. Do this 100 times. The pack will still work. The salt will still crystallize. The temperature will still reach 130 degrees. This isn't theory. It's repeatable, demonstrable physics. And once you've done it, you'll understand why the industry had to ban it. You can't sell subscription to something that lasts forever. The military connection. The U.S. Army has used sodium acetate heating packs for decades in cold weather survival kits. The M1950 Arctic heater was a canvas pouch containing a supersaturated salt solution with a trigger mechanism. Soldiers would activate the pack inside their sleeping bags to survive sub-zero nights. The military specification required the pack to reach 120 degrees within 30 seconds and maintain warmth for at least 6 hours. Sodium acetate met that spec. It still meets that spec. But the military doesn't care about recurring revenue. They care about saving lives. The civilian market doesn't have the same priority. The 3-pack rotation for 72 hours of continuous warmth. Build 3 sodium acetate packs, each 500 grams. On night 1, activate pack 1 at bedtime. It stays warm for 8 hours. In morning, while you make breakfast, boil pack 1 to recharge it. Pack 2 is active for the next 8 hours. Then pack 3. Then pack 1 again. With 3 packs and a heat source for recharging, you can have continuous warmth indefinitely. The packs don't need to cool down before recharging. You can boil them while they're still warm. The only limit is your access to a heat source. In a survival situation, you're already making fire for cooking and water purification. Recharging the packs adds no additional fuel cost. Why this knowledge is more important than ever. Winter blackouts are increasing. The grid is aging. Climate change is making extreme cold events more frequent. The industry solution is to sell you more equipment, generators, propane heaters, lithium batteries. But those solutions are expensive, fuel-dependent, and often dangerous indoors. The Babylonian salt trick is cheap, safe, and uses whatever heat you already have. It's a technology of resilience, not consumption. And that's exactly why they don't want you to know about it. The final step, make one this week. Buy sodium acetate online or from a chemical supply company. Spend $15 on a pound of crystals. Make 3 packs using freezer bags and metal discs. Test them, time them, learn how they behave. Then put 1 in your car emergency kit, 1 in your camping gear, and 1 in your home blackout box. You've just spent $15 on a heating system that will outlast you. The industry can ban the marketing. They can ban the labeling. They can't ban the physics. And they can't stop you from building it yourself.